edition Assessment Masterclass held by the UKSTT. My name's Luke Stedman. I'm going to be the chair for today, introducing the speakers and going through the questions. But first, we've got a bit of housekeeping to do, and then we'll go on to an introduction of the UKSTT for those who don't know it or aren't familiar. So there are no planned fire alarms today. So if you hear one, the fire exit is out here, up the stairs and out to the parking area. The toilets, if you haven't found them, are straight through this door to the right. They're not labelled very well, so I'm sure you'll find them. Smoking, there's designated spaces outside of this building. And please turn your phones off or put them on silent. I know that everyone works in business, so if you need to take a call, please just take it outside. But anyone's phone going off, we'd like to ask for a £10 donation to the charity Mind. So, sorry, I forgot to say, we're at the National Motorcycle Museum. There is free entry to everybody that's here, so during the breaks or areas that we've got a bit of downtime, feel free to have a walk around. It's an excellent museum, and feel free to use the space as you wish. So, the agenda for today. We've got the first session that will run from 9 till 10:30. We've got the first speaker about 9, 9:15. And that will run through a break from 10:30 till 11. There'll be refreshments and pastries on the side. Then we'll start back up 11 till 12:45, and there'll be 2 talks and then a discussion forum. So we're going to save the questions for the discussion forum. So any questions you may have, please write them down before we start that session. Then we're going to have lunch from 12:45 till 2 p.m. and again, feel free to use the facilities of the museum and have a look around the museum. Then from 2 till 3:15, we've got the third session of talkers, and again we're going to break out at 3:15, start again at 3:30 and finish at 4:45, possibly 4:30 with a second discussion forum. So I'm going to give you a quick introduction of the UKSTT for the guys, or for anyone in here that's not too sure about who we are.
So, yes. Can we get the air conditioning turned down, please?
Yes. Lynn, could we get the air conditioning turned down? I think we have mentioned it, so sorry. Keep your coats on for the moment. I know. It's better than being sweltering.
Of course.
So, United Kingdom Society of Trenchless Technology. It's a not-for-profit organisation, and it was formed in 1993 to promote the effective use of trenchless technology. We are also part of a founding society, which is the International Society of Trenchless Technology, and there's 28 affiliated societies, so throughout the world there's other societies that have joined this group of companies. It's made up of consultants, academia and professionals and manufacturers within the industry. The International Society of Trenchless Technology, they hold international events yearly, which quite a lot of you who are actively involved in the industry will attend through international business. There are affiliates of the association, all of which support us in several different ways, whether it's a meeting room, whether it's technical support, whether it's funding. So, in the top left, every year we hold an annual awards and a gala dinner, which is absolutely brilliantly attended. This year we're sold out. It's on the 19th of October in Leeds. The awards are a very good, very prestigious way for a business to either get into the industry or show off to their peers how well they're doing within a project or with a new technology. Every other year, so biennial No Dig live exhibition, it's held in Peterborough. We have mini masterclasses that are held in the morning. There's technical talks. There's great CPD events. So it's a very good way for the showcase of the industry. And as it picks up every year, it gets busier and busier. So maybe in the future we might look to do this as an annual event. There's national awareness presentations that happen throughout the year. And like I said, the technical and masterclass sessions are very good. And this being one of them, that we're able to, create a group of like-minded individuals to come together to be able to talk about a very specific subject. We've also carried these out on directional drilling in the past and on utility mapping. The University Outreach Programme, we're very active with the universities, trying to get more knowledge into the industry and actively engaging with the universities or the colleges and promoting what we do, and hopefully it's an industry that's going to boom in the future. And then we've got the regional roadshows. So these are smaller roadshows that are maybe on a specific subject sponsored by a company, in which member companies are able to present or also exhibit and network with their peers. So if you are not a member, I would strongly urge that you look into joining up. Lynn, who is our business development manager for the UKSTT, Lynn is about, but I think she's gone off to sort the air conditioning out. You can contact Lynn at this email address or call her, or just Google UKSTT. But I would urge you, it's been personally speaking, as a company that's joined, it's really helped us with the networking and with understanding technical knowledge and within our industry. We have a great website, and there's a free technical inquiry service. So a technical inquiry might come in, you might have an issue with you've picked up a load of work and part of it you've got to carry out a directional drill, for example. You might not quite know who to go to, what to do. So you can put in your technical inquiry to the UKSTT, and that will be sent out to all members and ask for feedback who can assist with this person in their inquiry. So again, it's a good way to even maybe pick up some new work. We have a newsletter that comes out. Again, industry news, very good. You can arrange your own CPD or technical event. So this is maybe one part of one of the road shows. If you as a company or you decide that you'd like to share your knowledge, you can get in contact with us and we can help arrange that. And then there's over 1,500 conference papers, such as today's presentations, if we get permission to be able to upload them or have them as part of this. Again, it adds to the learning and the technical advice that is available. And today's presentations are going to be filmed and will be put up on the UKSTT YouTube channel. So, let me hand over to Jon Boon from MWH. Jon is a technical director. He's got over 40 years involvement in both gravity and pressure pipelines. And Jon leads a team of pipeline specialists who are working on a wide range of pipeline activities. Thank you, Jon.
Thanks, Luke.
Thank you.
Luke's last words to me were, it's a technical presentation, something's bound to go wrong. So on that basis, I'll start and see how we go. So I'm looking fairly broadly at condition assessment, not just in terms of the tools that are available, but also looking at some of the thinking that goes around it. So I've divided it into 5 parts. One, just a general overview of condition assessment, then looking a bit more at consequences of failure, and then condition assessment costs, and finally looking at the very large range of techniques there are available for condition assessment, and then I'll just be summing all of that up. So, why do we do it in the first place? Well, we do it so that we can understand the condition of an asset and then decide what is the best way to intervene. And the best way to intervene can vary very widely. So it might mean making operational changes in the system. It might mean replacement, or it might mean rehabilitation. So we'll look at that in a bit more detail as we go on. So the principal thing we're doing is reducing risk. And risk is the product of likelihood and consequence. So condition assessment is principally looking at the likelihood part of that equation. So what we're doing is getting more information, so we understand the asset more, and so that we can make decisions about what we actually do. So we live in an industry where there are many old assets. There's also a lot of available information about those assets. Myself, I've been working recently looking at a pipeline in London, and the original drawings were done by Basil Jett over 150 years ago. So there's those kind of assets in terms of information, and there are many other kinds of assets, and we'll be looking at the different kinds of assets, and I put them in 3 different groups. And our challenge is how we actually collect information about those assets and how we interpret that information, and then deciding what we're actually going to do with it. But again, it's about the likelihood of problems on that particular asset. So this is a little bit of work done by the Foundation for Water Research in the US, and you can see the kind of areas that they think that condition assessment is driven by. Very often we're offered a problem, and that problem seems to relate to one pipe, and we get very fixed on finding out about that one pipe, but the drivers are actually wider than that. So again, condition assessment, likelihood of failure. We've got to look at the data that's available. We've got to make sure that we can use that data wisely. And the area we've been concentrating on as a company more recently is how we actually process that data. So I'll just talk a little bit about consequence now. Consequences of failure of a pipeline are clearly dominated by those 3 ideas. How big the pipe is, how much water it carries, the location, and the activities that go on around it and within the pipe. So when we begin to look at in detail at the consequences of failure, you can see there are many, many consequences of failure. So where we're heading on all of this is having a set of consequences, having a likelihood, and then deciding what we're going to do with that particular pipeline. So as I've said, we may be making operational changes. We may be ensuring that valves close more slowly. On the other hand, we may be doing a mix along the pipeline. Very often what we're doing when we're doing the condition assessment is actually deciding which bits of a pipeline do we need to take action on. And sometimes the particular bit of a pipeline we need to take action on is quite specific. And that, by addressing the particular area, can save us a lot of money. And finally, the last thing we really want to do is replace that pipeline. So, looking at that in another way, our first thing is to choose what we want to assess. So this is the outcome, the kind of things that we might do, and this is part of the process of choosing what we're going to do. So we know there's pressure on the asset owners. They want to prioritise what they're going to do. And we know that the costs are only likely to be highest with the larger diameters. And we need to look at our expenditure very much in context of what those failures might cost. Moving on a little bit, and this is what I meant earlier when I was talking about different kinds of information. We have three basic groups of information. So we have inferential information, and that might be the number of bursts per kilometre along the pipeline, or it might be soil corrosivity. Then we have discrete information. So it may well be that we've gone in and taken a little sample of pipe, and we know about that little sample in very high detail. Or there may be long length information. So people like WRC have technologies for going within a pipeline and surveying along the length of the pipeline. So our challenge is really, how do we deal with these three distinct groups of information? And I'll be talking a bit more about that towards the end. So here's some of the things that are important in the inferential sense. Quite a range of things. Some can be dealt with in desktop studies, bringing together all of this information, and that may help us to make that first pass of deciding which pipes need the most immediate attention. Then, as I say, we have a condition assessment approach. This is just measuring the thickness of the pipe in that particular location. And then we have technologies for looking along long lengths. So, just to summarise this first part, condition assessment is done to help us analyse the likelihood of failure. It's done to protect customers, and not least because we live within a regulatory environment. It can be done either discretely or in long lengths. What we have typically is a wealth of data, and having done that first pass on that wealth of data, we're probably going to decide what additional technologies we need to refine that knowledge. So I found it very difficult to get hold of this information, but eventually with the help of a colleague. So last financial year, 51,000 bursts. Now, what figure you ascribe to each burst, is really up to you, and there are different ways of ascribing a figure to the cost of burst. But if we just choose £3,000, then that gives us a total of 153 million cost just of those bursts. I always like to have one of my overseas photos because it shows the huge difference between what's going on in other places and how we are now dealing with things from a health and safety matter. But you can see here, a small failure can be a nuisance, but actually, if that failure persists, the loss of water can be quite significant. Small leaks don't get smaller. They might get smaller in rising mains where you can get, a small leak being blocked by the material in the rising main, but in water mains they don't get smaller. They just get bigger, and as we've seen, eventually those failures can be catastrophic. So our approach is to have a budget, to use the data, like the inferential information, carried through with both external and internal condition assessment, and then do the preparatory work for deciding what kind of technology we're going to do to understand the condition of the pipe. Sometimes it won't be necessary. Sometimes the desktop study will tell us what we need to know. So what do we need to think about here? We need to think about, the area that we're looking at. We need to think about the degree of resolution we'll get from the particular technology. Then we need to think about how we can enhance our confidence by using that data. At that point, decisions can be made. So, condition assessment is done to help us analyse, plan, and also we need to think about potential problems when we're actually doing the process. Looking at the costs, that initial desktop study can cost us a few £1,000s. If we need to go out because we have no external measurements of the condition of the pipe, we're talking about a few more thousands generally. And then if we're looking at really long lengths of pipe, we may be talking in terms of tens of thousands of pounds. If it's a large diameter pipeline, its asset value is potentially in the tens of millions of pounds. But this is just the first pass on the process. So we've got to make sure we've got the right technology. Generally, we're not looking at small diameter pipes. Currently, we're dealing with pipeline systems that were put together, and there was no view that in the future we would do condition assessment. One of the things I believe very strongly is that for larger diameter pipelines, and you could choose where that starts, but let's just say 900, 800 mil, we want to be able to get into those pipes. We want to be able to assess the condition of those pipes, because that's going to save us money in the long term. So we need to think about the ease of access. We need to think about the cost of getting insertion points into the pipe. We need to think about the device we're going to put in there. Is it going to cause turbidity? Is it going to get stuck? Do we need to empty the pipeline? And my feeling is very much when we're building a new pipeline, we should be thinking about these things, because no asset lives forever. And further down the road, we obviously want to maintain that asset in the cheapest possible way. So here we can see a range of technologies that I'll be talking about in a bit more detail later on. And you can see that we've got these lower cost technologies down at the bottom, all the way through to high resolution magnetic flux leakage, which is the technology of choice generally within the water and gas industries. Their position clearly is slightly different because they're not just thinking about the value of the asset, they're also thinking about the cost of the product. In our terms, as you get bigger, cost of the value of the product that might be lost and the consequences of its loss clearly pushes towards having better systems for understanding the condition of the pipe. Excuse me. So here's a couple of examples of things that are going on. Thames Water is putting points into its trunk mains so that they'll be able to get various systems within their pipes to assess the condition, look for leakage. Scottish Water, more recently, has had to create access points because it wanted to look at the condition of its pre-stressed concrete cylinder pipe. So we are beginning to see movements now within the industry to actually find ways of actually understanding the condition of the pipe and being able to monitor those conditions. As I've said, oil and gas transmission pipelines are regularly pigged, and therefore they have pig traps. That enables them to put things into the pipe and take them out again. That's true of both oil and gas. And my contention is when we get to these larger sizes, we need to be thinking about how we'll do it. I think that's a thought worth thinking about. Where is the greater problem? If your city runs out of water or your city runs out of fuel. One means you're going to have to bring in tankering and so on at huge cost. So this is an intelligent pig. And intelligent pigs bigger than this have already been used within the water industry. This is a pig trap, and you can see that what happens is at this end, you insert your device, you close this valve, open this valve, and your device is pushed along. Eventually, it will come in to some arrangement like this, and it enables you to trap your device, and that means you can take a huge amount of very high quality data at that point. So broadly speaking, lower diameter pipes, low cost method, larger pipes is probably worth doing internal assessment. And remember, some of those internal assessments can tell you information about the pitting and corrosion problems on the outside of the pipe as well as the inside. And new, larger pipelines, really pig traps should be considered. So summarising now on this section, it's being done to analyse, to help us understand the likelihood of failure, to protect your customers, and it can be done discreetly or in long lengths, and various types of data can be combined. So now I'm going to talk through various techniques, and as you can see, I've split them into those three basic areas. We now have very good technologies for looking at district metered areas. These are areas within a network where it's possible to measure what's going in and what's going out and what we don't understand. So that's generally referred to as non-revenue water. And that non-revenue water, if you can monitor that, if you understand the pattern of it throughout a year, if there's new leaks or new problems within the system, you can pick up that information. So this is one of our inferential sources. And again, we can start listening for leaks. So we have a range of different technologies we can apply to a pipe, and by measuring the time of flight from one sensor to another, we can estimate the location of a leak. So it's quite good at giving us a general indication, and if we know the number of leaks, it's a general indication of the condition of the pipe. This is a technology that is generally applied within networks, and as you can see, that kind of falls into our thinking about lower cost approaches for smaller diameter pipes. So it's just another kind of view of the kind of signal that you'll get. This can be done by driving around the place, and it can be done on a multi-point basis where you look at the results from many loggers. And clearly, the more loggers you have, the greater accuracy you're going to be able to say where leaks are. Soil resistivity, I can never get that out. If you can measure the resistance of the soil, that's an indication of the likelihood of corrosion in a particular area. Again, low cost. In this case, low cost, and you can cover fairly long lengths. There are difficulties, clearly, of doing it in urban areas, and this is one of the more highly inferential technologies. So looking now at the discrete techniques, we saw earlier measurements of the thickness in this slide here, but here we can see that we would map out the particular pipe we wanted to look at, and we take a series of readings of the wall thickness, the intersections of those lines. Gives us quite high resolution for that particular point. It's relatively low cost, and it can provide information generally about whether there's a generalized loss of wall thickness, and it will also pick up where we've got pitting. Clearly, it's designed for limited lengths, and there are certain materials like cast iron where it's a bit difficult getting fully accurate results. Magnetic flux leakage is a way of picking up anomalies in the pipe wall by applying a magnetic flux. If you can imagine, you've got two magnets, and the magnetic lines would like to flow directly from one magnet to another. If there's a change in the wall thickness, it's difficult for all those lines to go through, and therefore some of the flux leaks out, and you can measure that flux leakage, which relates to change in wall thickness. This can give us higher resolution than acoustic methods, and we can look at the whole of the wall, but typically only over a relatively limited area. And again, it can pick up both internal and external limited area, can be used in conjunction with other systems, but again, can be a bit problematic on cast iron. Broadband electromagnetic scanning looks at the attenuation of a magnetic signal. Can be used on pipes from about 75 mil upwards, and it can be used without removal of the coating. So that's often an important factor in our overall costs. You know, do we have to remove the coating? Do we have to put the coating back? So it's all part of the process of understanding those costs. So you can see the area being inspected is relatively small. In certain instances, you might be prepared to move that along a bit. So we can see, I think that slide's out of order actually. Moving on to internal leakage detection. As you can see, we can look at long survey lengths, and these technologies can tell us the position of leaks very accurately. Sometimes they can provide CCTV, and very usefully, they can provide joint counting. And the reason I say that's very useful is because if you imagine you've done a number of discrete analyses along the pipe, or have a number of points where there have been bursts along the pipe in the past, this helps you locate regions in the pipe very much better. And a recent job where we worked on, it was very useful to be able to know exactly which pipe you were at because of this ability to identify the position of various joints. There are other technologies which go inside the pipe. Their ability to locate with that high level of accuracy that you get with a tethered system is lower. But maybe that doesn't matter too much, because if you get the general location of a leak from a system like this, you can go in later and pick up the exact location. And again, this technology now has the ability to identify the position of individual joints. And sometimes, and we've had one occasion where we were combining both technologies, that was extremely useful for understanding exactly what was happening in different areas. As you can see, this is the signal from the joint. There may be other signals that come through, but at the moment we principally use this technology for looking at the individual joints. One of the great things about an untethered technology is that it allows you to look at very long lengths. So if you can put something in there and you can be sure that there's no diversions or anything, you may be able to go for tens of kilometres and get information about that pipe. The tracking, as I say, is a bit inferential, but there are ways around that, and there's always a potential to lose your device. There are a range of technologies that enable you to go inside a pipe and get information about the pipe. This particular technology, Pipe Diver, is similar to SmartBall in that it's untethered, it can go very long distances. Some of these technologies, as we've seen, actually require a man to go in there and push the system along. This is a Norwegian technology. It works on an acoustic basis, sends out a signal, looks at the signal that comes back. This is another way of looking at things, fairly simple looking device, but we have an exciter and a detector looking at the information generated by the pipe due to the signal that we put in it. We saw earlier that you can use broadband electromagnetics on the outside. It's also possible to use it on the inside of the pipe. I'm not aware of anybody doing this in the wet condition, but it can certainly be used in the dry condition. Now, I've returned to this particular slide because, as you can see, this is quite a complex device. It has quite a number of different parts to it, and I'll be explaining why that is in a minute. So, inline inspection, the different technologies on that pig. One technology can use axial magnetic flux leakage, and it can cover that area. Another uses circumferential MFL, and it can cover that area. And then we have radial ultrasonic technology. So you can see that there are a whole range of different technologies, and that allows you to look at different elements. Funnily enough, none of them seems to manage to get into that area. So some of these, even though you've got a very complex device, a single pinhole going through, it won't necessarily pick that up. And this can be done both in out-of-service pipelines and in-service pipelines. Perhaps one of the best examples of the use of this technology was in San Francisco, where they have a viaduct called the Hetch-Hetchy Viaduct, and it supplies from a big lake reservoir system to San Francisco. And there had been a number of failures over the years. And so a lady called Margaret Rutherford, who was in charge, she decided that they would apply magnetic flux leakage technology. And it was twin pipeline, so they were able to take one pipeline out of commission and then explore that pipeline for problem pipes. And in the end, that's what turned out to be the case. They already had a budget of $56 million to go and replace these pipelines. But by applying this technology, they were able to identify that the actual problem areas and the problem pipes were very limited. And in the end, they went into the system, they addressed those pipes, and they saved a huge amount of money not having to do a replacement pipelines. So I'll talk a bit about pre-stressed concrete cylinder pipe. We don't have a lot of it in this country. You can see here that when it fails in quite a big way. And there's an additional component to these failures, and that is these wires are pre-stressed onto the pipe. So the actual failures tend to be fairly exciting events, shall we say. Technologies now exist for counting the numbers of breaks in those wires. That just gives you the feeling of the structure. So these kinds of pipes, you can look at them when the pipe is empty. Again, you have an exciter and a receiver that takes this information and gives us this information about the number of wire breaks. And there are also technologies like this, where you put the pipe diver device into the pipeline, and as it passes along the pipeline, it basically does a very similar function to this equipment, picking up anomalies. And you can see here that this is the kind of information. Clearly there's a lot of interpretation that has to be done to pick up that level of information, but there are companies out there who can do that. So now I'd like to move on to the area I've talked about, kind of hinted at, which is combining data sources. We can see there's lots of potential data sources. So many water companies in the UK divide their system up into span IDs or SAPIDs. People have different names for them. And within a particular span ID, you'll have information about age, wall thickness, pressure, pipe material, soil type, the burst history, the land use. You can then take these weightings, which we would normally choose dependent on a range of factors, including what is most important to the water company. And we can produce a normalized likelihood of failure along that pipeline. Now, that kind of approach is generally used for long pipelines. It's not a very high-level resolution approach, but it would be part, perhaps, of an initial desktop study before you decided to focus on other areas. That's not too clear. This is what we would do if we had a lot of information, both internal information, external. So this actually reads structural scores, water loss scores, environmental scores, susceptibility scores, and aggregated corrosion scores. And this was another technology we were looking at the time, right at the bottom, pipe wall assessment. So you can see, in some cases, we are very information rich. Then we have to say to ourselves, how can we actually use this information? And we have developed algorithms for combining this information. And that gives us a lot of data about the condition of the pipeline. We can see that in areas like here, there's quite a lot of problems. In areas here, there's still some problems. Areas like this, we can see the pipe is in very good condition. So there are ways of taking all of this information and processing it into a very meaningful set of data about that pipe, that particular pipe. And this is the area where MWH has been focusing lately. Now, unfortunately, I can't run this at the moment within a PowerPoint environment. But having got all this information, if it's a relatively short length, we can do that. If we've got a long length and we need to go to the MD and say we need capital spend for this kind of length of pipeline, we can now produce BIM models that allow us to basically fly along the pipeline, and then we can pick up and colour code for the risk, consequence, likelihood. We can identify each of those. We can pick up on the pressure, we can pick up on the material, we can take the ground off or put the ground on, and we can look at a whole array of different things and make that information meaningful. And I think, both of these concepts of how we deal with these many different kinds of data and how we display these many kinds of data is very important going forward. So just in summary of the techniques, we've got a very wide range of techniques, some inferential, some discrete, others long lengths. We now have good algorithms for combining all this information, and there are new ways of visualizing it. So I just want to conclude now. We start looking at things like budget, the area of the pipe that we need to look at, the level of resolution that we're going to apply. We're going to ensure that we have a way of processing that information to make it meaningful, and at the end of the day, we should have sufficient information to allow meaningful decisions. And those decisions are likely to fall into these four categories. Do nothing, everything's fine. Change operating conditions, and that might mean that you remove fast closing valves that could cause surge, or a number of other ways forward. We can then decide whether we want to go for rehabilitation or replacement of the pipe. So in conclusion, over the last 10 years or so, we've seen very rapid development of a range of different technologies that enable us to do condition assessment. There are parts of the industry who are not always aware of the range of these technologies, and this kind of approach to condition assessment is not generally part of strategic planning, but we are entering a new era in which it could be. So that ends my presentation. Thank you very much indeed for listening.
Thank you, John. Very informative and a great presentation. Well done. I also cannot say resisted. I
You just did.
I did, yes. So next up, we've got Charles Ashdown from Exova.